Now with the index block, there are two problems. One problem is sometimes if we have very less number of blocks allocated to a file, then entire block has to be allocated to the file, which is going to lead us to internal fragmentation, which means that index block is not going to be completely filled, right? Completely full. So that is a problem which we cannot do anything about. But then the other problem is if the size of the index is too large, which means the number of blocks which are allocated to a file, if they are going to be too many, in that case you might have to have lot of entries in the index block, and the index block, one index block or one data block cannot hold all the pointers, right? In that case, what to do? Let's see this. Now see this one. If the index block is too small, however, it will not be able to hold enough pointers to hold for the large file. So it means that if the file is very large, okay, and now if our index block is very small, then the number of pointers it can hold will be very less, which means it will not be able to hold all the index all the pointers there in the index node. Now what we should do in that case is, instead of maintaining one index node, we can maintain many index nodes. Now the problem is, how are you going to access all these index nodes? There are two implementations, there are many implementations. Let's see one by one. Now let's see the linked schema. In this linked schema, we are going to have one index block, and in the index block, okay, see this is called let us assume that this is the first index block. It is going to contain some disk addresses, and at the end we are going to have a pointer. Now this pointer is pointing to the other index block or the next index block, which will contain some more pointers. And also remember that in the index block, along with the disk addresses, which means the block addresses, it is going to have even some attributes. Every file is going to have some attributes associated with it. You are supposed to maintain those attributes also in the index block, right? So index block is going to contain attributes, along with that some pointers, which are nothing but the disk blocks into which our file is being stored in. And if it is too small, then we are going to create one more, right? Let's say one more block, and in this in this block we are going to have again disk pointers. Now if it is also not enough, then we'll create one more, and again this is also going to contain some data, some pointers, and again one more pointer to the next one. So like that we are going to have many pointers, right? So this is the linked schema, which means that we are going to implement it as if it is a linked list, right? And now let's see the other way. The other one is multi-level indexing. So it is exactly same way you might have seen in B trees and B plus trees, right? So here in the outer we are having levels of indices. Now in the outer level index we are going to have some pointers, and now these pointers are going to point to some blocks, and now these blocks are going to contain the disk addresses, right? And the first block is supposed to contain the attributes as well, and all the remaining blocks are going to contain the blocks, this disk block addresses. Alright, so this is the multi-level implementation, and the earlier whatever I have shown you is the linked implementation. We can have a hybrid implementation as well, in which we are going to combine these two concepts. We shall see it. Okay.